Hey guys, it's Mrs. Wallace. I suggested that I would just finish some of our class lesson today via video because I didn't get a chance to finish the lesson about combining resources, but this is something that you'll need to know for the homework. There's two assignments, right? One is a description of this lesson. It's called Combining Resources, and it's a handout, a PDF file. It's only 2 pages long. It has a couple of practice questions about two concepts. One is going to be called the least cost rule, and the other is called the profit maximizing rule. Both of these are going to be ways in which to combine resources if you happen to be a firm that's interested in not just hiring workers, but you're interested in hiring workers and also maybe renting some capital, okay? So or any other type of resources. You could be a cake baker and have multiple resources, and of course you're looking to combine those resources in the right quantities, right? It's not only about just getting the right amount of flour, you also need the right amount of, sugar or the right amount of other resources that you need as well, okay? So everything about this is appropriate for firms that are combining resources. There's two homework assignments, both have for Thursday. One is submitted and graded, and that is the problem set 1 and 2, and that was in the folder from last class on April 27th. The assignment to practice, so that this lesson kind of, you get a chance to work with it a little bit, have for Thursday, so we see if you have any questions. That's in today's folder. Okie doke? Okay, so the first of the important rules, in one way that firms make decisions related to combination of resources, is the least cost rule. And some of you may have seen this in class, depending on what section you were in. If you saw this in class, just go to the next, just flip ahead a little bit to profit maximizing rule. But least cost rule, we kind of follow a rule of thumb that's based on two things. One is we're really interested in marginal product, because in order to figure out what resource you want to use, say that you're interested in both, you're producing some sort of jeans or something like that, and you want to hire workers who can make the jeans. You also are hiring, robots or some type of capital to make the jeans. There's two things that are going to be different, right, with these two resources. One resource may be more productive than the other, so we're interested in marginal product. And, just at first glance, if we wanted to, we can see that if we just kind of put a line here, what's in blue is associated with the robot. And we can see the very first robot has a marginal product of 30, right? They can make 30 pairs of jeans. One robot can pump out 30 pairs of jeans. The worker, on the other hand, can pump out 20 pairs of jeans. So the worker is not as productive, as the robot is. However, it's not only marginal product that we're interested in, we're also concerned about the price of the resource, okay? So even if robots are a lot more productive, doesn't necessarily mean that we should only buy robots. We might consider looking at workers because, workers are a lot cheaper than robots. So the marginal product per dollar that's spent matters. And remember, in perfectly competitive resource markets, this is a constant thing. The price of labor or the price or rental fee for capital is something that's constant, okay? So we're really going to be looking at the marginal product over the price of the resource, whether that's the price of the labor, the wage, the constant wage, or the rental price of capital, okay? So even though the robot is more productive in this example, the very first robot produces 30 jeans, but actually costs the firm $10. So it's almost as if there's kind of a $3 your not $3, your marginal product is 3 for every dollar that you spend, right? Each robot is pumping out 3 pairs of jeans for every dollar that the firm is paying of this $10 cost. On the other hand, the very first worker is actually pumping out 4 pairs of jeans because their wages are cheaper than the robot. So even though the resource is less productive, it's actually pumping out more per dollar. And if we kind of do the math with the marginal product per price, we can kind of see something like this. That's a 2. Sorry, my it's a little tricky to draw with my finger here. And this is 3, and this is 2, and this is 1. So in this example, sorry, I can't seem to draw the 3 there. In this example, if we have a set budget of $35, and this is going to remind you a lot of the utility problems that we used to do when we were looking at marginal utility. Somebody had a budget and they were buying apples and oranges and they were trying to decide, how much of each they could purchase with, say, a budget of a certain amount of money. The firm is following that same entire, kind of theory. They have $35 in this case. They have $35 to spend. They are going to purchase a certain quantity of both workers and a certain quantity of robots. Okay, so will they buy the first worker? Yes. In fact, that's the first place they're going to put their money because that's where the marginal product per dollar is higher. Okay, they're also going to then buy perhaps either they're indifferent to the next worker or the next robot, and by this time they've already spent $20. They're going to continue to purchase up until the point where they're going to have 3 workers and 2 robots. They will have expended all of their $35 and they would ensure that they are following the least cost rule. Okay, and the idea here is that you're looking at the marginal product over the price of labor to essentially be equal to, for the very last dollar that gets spent, that very last worker and that very last capital resource that's purchased, there should be an even marginal product over price. So marginal product over the price of labor should be equal to the marginal product over the price of capital. K is often used for capital in economics. Okay, so there should be equivalent here. And if you're ever in a situation where one side of the fraction, there's one side of this formula is greater than the other, if, for example, the marginal product of labor was, for the last worker hired was 10, but the marginal product for capital was like 8, okay, then ultimately you should put more dollars into labor. It gives you the greater marginal product per price, and as you put more funds toward purchasing more resources, the marginal product will diminish because of diminishing returns, and ultimately you will have an even fraction, so that the very, very last worker, and we see that here, the last worker and the last robot that might be purchased by the firm, we see that there's an evenness in terms of the marginal product over the price. Okay, I hope that's helpful, and we'll look at the next profit maximizing rule in a sec. Okay, guys, so just take note on the top of the screen, the least cost rule. Okay, that's really the very key thing about this lesson is that this is the least cost rule. Okay, we wrote it on the last, but the marginal product of labor over the price of labor should be equal to the marginal product of capital over the price of capital. And you could have any number of resources in this. You could go on and on and on and on and include the marginal product of flour over the price of flour and the marginal product of other things. So anytime you're combining resources, you're looking at using your scarce kind of dollars to ensure that the distribution of those dollars is going to go to the right quantity of resources, and you're ensuring that based on the least cost rule. Okay, you're just kind of continually purchasing and evening out, in a sense, all of the marginal product per dollar. Okay, if another resource can get you more bang for the buck, literally you're going to purchase more of that resource and then less of the other. Okay, all right, so let me okay, guys, so this is the profit maximizing rule. Note that this is very, very different than the least cost rule. Okay, so it's important to recognize the language here, the vocabulary. This is profit maximizing rule for combining resources. The last one had marginal product that we were interested in. This one, it's not marginal product, but it's actually marginal revenue product that we're interested in. And we're also going to be interested in the MRC, which is also kind of the price of labor, okay, or the price of capital in perfect competition, okay. Think of it like this. Maybe this particular rule suggests that if a firm is profit maximizing, and we kind of know what this looks like, right? If we have a firm that is hiring workers, and this is going to be MRP, and this is MRC, we know that a firm hiring workers will actually purchase, this quantity of workers, where MRP is equal to MRC. If that's true for labor, then a firm is profit maximizing when they purchase that quantity of labor. If they're purchasing multiple resources, okay, all this means is that they're profit maximizing with every single resource that they're purchasing. So if they're also purchasing or renting capital, the MRP of capital, okay, and the MRC of capital also helps to define the intersection between those two, helps to define the quantity that would be appropriate to purchase of capital. Now, these numbers may be very different, right? The quantity may be much bigger for labor than it is for the quantity for capital. It might also be the case that the number where MRC is equal to MRP might be $10 here, and so you might have 10 here, but where MRP equals MRC for another spot, okay, might be 12, right? It might be $12. The key thing with this is that it doesn't necessarily mean that 10 has to equal 12. The where MRP is intersecting with MRC doesn't necessarily have to be the same number, but if MRP is equal to MRC, this fraction will always be 1. And it should be 1 for labor, and it should be 1 for capital, 1 for flour, or whatever, okay? So if MRP is equal to MRC at $10 for labor, but for capital, it's 12 over 12, okay? Both of these are not equal to each other, but they are equal to 1, okay? So that is the key with the profit maximizing rule. And if you are profit maximizing, you are purchasing each resource at the quantity where MRC equals MRP for each and every resource, even if you have 50 of them, you are also, by default, least cost, okay? Profit maximizing implies least cost. However, you can be least cost and not profit maximizing, okay? Check out the handout from today's class to look at that. There's some important, like, kind of maybe algebraic relationships to look at. We'll talk about it more in class. Okie doke. Have a good rest of the day, guys.